Hello friends, let's find the value of x if four nested square roots of x together equal 9. Let's solve this carefully step by step. We are given that 4 nested square roots of x equals 9. The first thing we're going to do is remove one square root layer by squaring both sides of the equation. The reason we can do this is because if two quantities are equal, then their squares are also equal. So we have the quantity containing the 4 nested square roots of x, all squared, equals 9 squared. Now notice what happens here. When we square a square root, the outermost square root disappears because square root of x whole squared simply becomes x. So after simplifying, we get x multiplied by 3 remaining nested square roots of x equals 9 squared. If you're enjoying this step-by-step explanation, don't forget to like the video because we're solving every step without skipping anything. Now, let's continue. We still have 3 nested square roots left, so we'll use exactly the same idea again. Square. Both sides once more. We get the quantity x multiplied by the 3 remaining nested square roots of x, all squared, equals the quantity 9 squared, all squared. Now let's expand the left-hand side carefully. Remember the exponent rule, which says a power raised to another power means we multiply the exponents. So, x whole squared becomes x squared, while the remaining nested square roots are also squared together. This gives us x squared multiplied by the quantity containing the 3 nested square roots of x, all squared, equals 9 raised to the power 4. Once again, the square removes one outer square root, so the remaining expression becomes x squared multiplied by x, multiplied by 2 nested square roots of x equals 9, raised to the power 4. Now pay attention to the simplification. We use the law of exponents, which says when multiplying powers with the same base, we add their exponents. X squared multiplied by x becomes x cubed. So now we have x cubed multiplied by 2 nested square roots of x equals 9 raised to the power 4. We still have 2 nested square roots remaining, so let's repeat the same process. Square both sides again. We get the quantity x cubed multiplied by the 2 nested square roots of x, all squared, equals the quantity 9 raised to the power 4 all squared. Expanding the left-hand side gives x cubed whole squared multiplied by the quantity containing the 2 nested square roots of x, all squared, equals 9 raised to the power 8. Now, x cubed whole squared becomes x raised to the power 6 because 3 multiplied by 2 equals 6. Also, squaring the remaining nested square roots removes one more square root layer. So we obtain x raised to the power 6 multiplied by x multiplied by one remaining square root of x equals 9 raised to the power 8. Again, combine the powers of x. X raised to the power 6 multiplied by x becomes x raised to the power 7. Therefore, we have x raised to the power 7 multiplied by the square root of x equals 9 raised to the power 8. We still have one square root left, so let's remove it by squaring both sides one final time. We get x raised to the power 7 whole squared multiplied by the square root of x whole squared equals the quantity 9 raised to the power 8 all squared. Simplifying this gives x raised to the power 14 multiplied by x equals 9 raised to the power 16 because the square root of x squared is simply x. Now combine the powers one last time. X raised to the power 14 multiplied by x raised to the power 1 equals x raised to the power 15. So we have x raised to the power 15 equals 9 raised to the power 16. To isolate x, we raise both sides to the power 1 divided by 15. The exponent rule tells us that when a power is raised to another power, the exponents multiply. So, x raised to the power 15 multiplied by 1 divided by 15 equals 9 raised to the power 16 multiplied by 1 divided by 15. The 15s cancel on the left-hand side, leaving simply x equals 9 raised to the power 16 divided by 15. Therefore, the value of x is 9 raised to the power 16 divided by 15.